In this final task, I'll combine all the individual parameters into one layer, representing the combination of all parameters. This will represent the acceptable area for helipad locations. Then I'll run a clip algorithm on the airports to determine which airports meet all the criteria. I have QGIS Desktop open with the project, and I will open up the graphical modeler, click the Open button, and select my model to open it. I'll expand the window so I can see the entire model. In the last task, we created the ring around Corpus Christi city limits. We buffered the county road layer, and we buffered the water features. So these are the three big criteria for our site selection model. I can combine the water buffer, county roads buffer, and the 3-mile ring around Corpus Christi using the intersect algorithm. This will compute the area of overlap between the three layers. So I'm going to add the intersect algorithm. I'll click on the Algorithms tab, expand QGIS Geo Algorithms, expand Vector Overlay Tools, and double-click on Intersection. The input layer is going to be the difference from Algorithm 4. The intersect layer is going to be the output from Algorithm 6. I'll scroll down until I find buffer from Algorithm 6. I'll call the output intersection. Now this is only 2 of the 3 parameters for the site selection. So I'll click on this ellipsis button, which opens the multiple selection window and allows me to add extra inputs to this intersection tool. And I'll choose number 8, the fixed distance buffer, click OK, and click OK. And just to make sure this model looks correct, I'm going to save it and click Close. Expand Models, GST 102, and right-click on my model and choose Edit Model. Open it back up again, and I can see again now that the model's been refreshed that I've got intersection combining those last 3 layers. After this, ideally, we would include a clip, or you could just as effectively use a select by location, feeding into that the Nueces airports layer and clipping those by the result of the intersection, or selecting by location based on intersection. Unfortunately, there is a brand new bug that prevents this last algorithm from working with this model. So we're going to do that last part manually, and that's part of the reason we exported the intersection to a layer. I'll go ahead and save the model and close. I'll expand it, and I'll double click it to run it. So here's my custom tool that I've created. I'll simply choose the parameters. Counties is the counties layer. The county attribute is county. Airports is the airports layer. I'll choose city boundaries for city boundaries. The city boundaries attribute is name. Roads is already chosen for roads layer. The attribute for roads is route type. Select water features for water features. And now I will choose to save out these 3 outputs to my data folder. So I'll click the ellipsis button, save to file. I'll call this Nueces County.shape. Click the ellipsis button for airports, save to file. Save this as Nueces Airports.shape. And the intersection layer. I'll just call this intersection. Okay, now I've got my form populated, and I'll click Run to run the tool. And you'll see that you get switched to the log tab, and it provides all the output of what's happened. Okay, the model finishes running. I've got the Nueces County layer, the airports layer, and the intersection. I'm going to drag intersection below airports. And now I'm just going to manually do the last task, which would be a clip. So I will go to the vector data menu, to geoprocessing tools, clip. I'll select the Nueces airports as the input vector layer. The clip layer is intersection, and my output shapefile is going to be the final solution. And call this final solution. Click Add Result to Canvas and click OK. And close. Here's my final solution. Open up the attribute table and see there's just one airport that meets all the criteria. One note on this bug that prevented me from adding the final clip to the model. This is an issue that isn't happening with all installations of QGIS right now. It depends on how the software was installed and what platform you're running. So there'll be some installations where this will work flawlessly. It does in fact work on my Windows installation using OSGeo for Windows as the installer. I just wanted to show the safest workaround, the most reliable workaround to do this. So we had to do the last step manually, but the model itself is still quite robust. So in this lab, you've been exposed to both site selection modeling and the use of the graphical modeler in building a workflow. So building the model is certainly time consuming. However, the benefits are many, especially if this is a workflow you're going to have to perform many times. I'll open up the graphical modeler one more time just to show you there's this button, Export as Image. When you have your model open, you can click that Export Model as Image and export a graphic of the model that could then be included in a presentation or a document such as a report, which can help explain the technical workflow to others. Another benefit of having this workflow set up in the graphical modeler is, let's say the client changed their mind on the distance from Corpus Christi. You could simply adjust that buffer distance in the model and rerun it to see how the solution changed. Without this model, you'd have to start from scratch in that scenario. The model can now be run against a similar set of data at a different site as well, such as Seattle or Boston. So if you were to run against another set of data, some of the parameters of the extract by attribute would have to be edited. However, that's easily done. So models really allow you to streamline big workflows.